This is pre-algebra extension lesson 9-3, angles of a polygon. The sum of the measures of every triangle is 180 degrees. If you have not learned this in a previous math class, I will explain this at this point in time. If we were to take this triangle like we have right here, and we were to label the angles A, B, and C, like we've done A, B, and C, and we were to tear the angles off, we were to cut this triangle out of a piece of paper, label the angles A, B, C, we were to tear them off and then line them up, you'll notice they go together and fit together and make a straight line, and a straight line is 180 degrees. Therefore, all three angles of a triangle have to equal 180 degrees. Knowing this, if we looked at some other polygons, we can figure out a pattern of their angle measurements. For example, if I have a triangle, the triangle's formed from one vertex. If I choose this as my one vertex, there's only one triangle formed. We already learned that that's 180 degrees. So that would be 180 degrees. If I had a quadrilateral, if I chose this vertex, if I was to draw a dashed line here, I have two triangles formed. One triangle is 180 degrees, the second triangle is 180 degrees. We add those together, we get 360 degrees. If I have a five-sided figure, 1, 2, 3, 4, 5. If I was to create triangles from one vertex, let's say this one, okay? I can create 1, 2, 3 triangles. If I took 180 degrees and I multiplied it by 3, I would get 540 degrees. So that's how you get the sum of the measures of all of those angles. If I was to take a six-sided figure, 1, 2, 3, 4, 5, 6, and for ease I'll make it a different color. If I was to draw all the diagonals from this, or all the triangles I could draw in from this vertex, you'll see I have 1, 2, 3, 4 triangles. So if I took 180 and multiplied that by 4, we would get 720. If we continue this pattern, if I have a seven-sided figure, 1, 2, 3, 4, 5, 6. I didn't do that very well. Let me try that again. I went in too soon. 1, 2, 3, 4, 5, 6, 7. There's a seven-sided figure. If I was to draw all of the triangles from one vertex, there's 1, 2, not very good straight lines on top. Okay, so I have 1, 2, 3, 4, 5 triangles. 180 times 5 is going to equal the number of degrees in that triangle. That would be 900 degrees. My last figure is 8 sides. I'll try to draw this, squeeze this in over the other side. 1, 2, 3, 4, 5, 6, 7, 8. It's kind of like a stop sign. I was to draw in all of the triangles. We have 1, 2, 3, 4, 5, 6. So 6 times 180 is equal to 1,080. So this would be, oh, sorry, I forgot to say there's 5 triangles here. There's 6 triangles here, which would be 1,080. Now, if you look at this, we can find a pattern. We talked about finding patterns before. If we look from here to here, we should see a consistency here. When I had 3 sides, I had 1 triangle. 4 sides was 2 triangles. 5 sides was 3 triangles. 6 sides was 4. 7 sides was 5. And 8 was 6. We were always going down 2, weren't we? We subtracted 2 from the number of sides we had. So if I know I have n number of sides, I'm going to go n minus 2. And then from here to here, we multiplied by 180. From here to here, we multiplied by 180. From here to here, we multiplied by 180. And we kept doing that all the way around. So if I have n number of sides, I need to subtract 2 from that and get 180. Okay, so my formula would be n minus 2 times 180. That's the formula we can use to solve, okay, oh, actually I shouldn't hit 180 up here, it should be just my n minus 2. That's the formula we can use to find the sum of the measures of any angles of any polygon. Okay, and I've summarized that below here. It says, notice for each polygon, the triangles formed from one vertex is always 2 less than the number of sides, and the sum of the measures of the angles of the polygon is always the triangles formed multiplied by 180. Therefore, the formula is n minus 2 times 180. Right there. And how do we apply this formula, you might ask? Okay, let's take a look at it. Find the sum of the measures of the angles of each polygon. Okay, we're going to find the sum of the measures of an octagon. We're not going to look at the chart we just made. We're going to actually do it the other way. So an octagon has 8 sides. This is 8 sides. And the formula is n minus 2 times 180, where n equals the number of sides. That's what the formula stands for, and n is the number of sides. So if I have 8 sides, I'm going to have 8 minus 2 times 180, which is 6 times 180. And if you take 6 and multiply it by 180, you should get 720 degrees. So there are 720 degrees in an octagon. Let's look at a quadrilateral. A quadrilateral is 4 sides. So the formula says 4 minus 2 times 180, which is 2 times 180, which is 360 degrees. So far, so good. These are all ones you could check with the chart on earlier in the lesson. A decagon. This one we can't check it, so we didn't do it. Decagon is how many sides? It's 10 sides. Since this has 10 sides, it would be 10 minus 2 times 180. So it would be 8 times 180. And of course, I would suggest to you to use your calculator so that you don't make a mistake. This equals 1,440 degrees. Oops, got my zero. 1,440 degrees. There we go. A 27gon. A 27gon has 27 sides. So that would be 27 minus 2 times 180. Well, 27 minus 2 is 25. 25 times 180 is 4,500. A lot of degrees in this polygon. Now, if we can find the total number of degrees in the figure, the sum of all of the measures, we should be able to go backwards. If I give you the sum of all of the measures, you should be able to find the number of sides that it has. This is just taking the same formula and kind of working it backwards. The formula is n minus 2 times 180. That gives us the sum of the angles. So if we think about that, we can use that formula in the reverse to find the number of sides. So we can take that sum and we can plug it into the formula to find n. For example, in this first example, I tell you that the sum of the measures is 1,080. How many sides does it have? Okay, so we're going to figure out how many sides it has. So the first thing I'm going to do is I'm going to say the sum equals n minus 2 times 180. I'm going to write my formula down. Then I'm going to plug into my formula. This is my sum, so that will go in where 1,080 is. So 1,080 is going to equal n minus 2 times 180. The easiest way to solve this, okay, is to divide by 180. Okay? So if I take, because I need to get n by itself, so the first thing I'm going to do is I'm going to get rid of the multiplication. I could distribute it, but it's harder. So I'm going to get rid of the 180, so these two cancel out. If I take 1,080 and divide it by 180, I'm going to get 6. 6 equals n minus 2. But I don't want to solve for n minus 2, I want to solve for n, so I'm going to add 2. So n equals 8 sides. Let's do this a couple more times. What happens if this sum is 4,140? So my sum equals n minus 2 times 180. This is just using algebra skills. We're going to plug in 4,140 for the sum. 4,140 will equal n minus 2 times 180. Divide both sides by 180. These two will cancel out. 4,140 divided by 180 is 23. So 23 equals n minus 2. Add 2. And 25 sides equals n. N is 25 sides, so if it has 4,140 degrees in the total sum, it has 25 sides. Let's do these last two. If it has 18,000 degrees, it's obviously going to have more than 25 sides. So the sum equals n minus 2 times 180. So first thing we're going to do, 18,000 equals n minus 2 times 180. Divide by 180. Right, 18,000 divided by 180, you should be able to do that one in your head, is 100. That's going to equal n minus 2, add 2. So we'll have 102 sides. So my figure has 102 sides. I'm not sure I could draw one of those very accurately. It's going to be close to a circle. The more sides it has, the closer to being a round figure it's going to be. And let's do the last one, 1,620. So 1,620 will equal n minus 2 times 180. Divide by 180. 1620 divided by 180 equals 9. 9 equals n minus 2. Add 2. And we'll have 11 sides. And this is how we find the sum of all the measures of a particular polygon, or how many sides a particular polygon has if we're given the number of degrees in the figure itself.